Access Solutions.
Okay guys, so today we're planning to create a circuit, and this is a step down circuit. We're going to transform 12 volt DC to 5 DC. So I have some capacitors here like this microfarad, 10 microfarad capacitor, and some connectors. I also have these small drill bits here for my Lotus rotary tool, and I'm gonna be using this one for drilling holes to the PCB. So for starter, I had to assemble this 7805 to the heatsink. The heatsink at the back will absorb the heat. So what I'm doing in this part is that I'm drawing on top of the PCB where the current will flow later after I remove the coppers on the sides, on the areas where I did not draw. So as you can see, I am using a pencil pen, a permanent one, permanent marker, to draw the circuit lines. Later we will use the ferrous sulfate to clear the PCB board of the coppers. So it's a bit different. Yeah. So because I made a mistake in here, so I'll just have to increase the size from the side. Let's John, please.
Ferric chloride pure. Pour it on it.
Pour it on the stop. To shake it. Okay, so we have these two PCB board in a cup, plastic cup to be exact, and we're using ferric chloride to melt the what do you call this, the copper on the PCB board.
What should we see? Like what color? Green.
It's like the plastic at the back, like that one. Yeah, like what was the? Wait, I'll post it.
The sides. Can you see the sides? These ones, yeah.
Yeah, something like that. Okay, so keep on.
Sides. Keep on shaking it.
Shake.
Shake. Should I shake it faster, right?
So how can I see? What does it look like?
See, this one is really, I think it's coming off.
Oh yeah. It's like yeah. You're losing the. Okay, it's dissolving now, right?
Yeah. So I think I should shake it faster.
I will just pour some more, so you don't need to shake. What do you think? But it's a waste.
Really?
Huh?
Should we pour some more?
Pour some more and just leave it underneath, and then you keep the ferric sulfate, right?
Okay.
Pour some more and just leave it. Oh, but it's dissolving already. Huh?
Yeah, so it's okay.
Musky, right?
Musky. Wasting it.
Do you know what you call this thing? Ferric sulfate.
I think it's very easy, like instant death, right?
Oh, don't drink it.
This one's in instant death.
You see what it does to copper, right? It burns it. Dissolves it. Right?
If it can bend copper, then
Hey, look at that. It's disappearing now, right?
Yeah. This one. The first one.
Okay, I'll come back. Diametric.
Bakit?
May 12 volts. So kailangan i-step down. 5 volts. Okay, ha?
How will I hold it? Can I hold it with my hands?
Yes.
One
Pour
bend.
this liquid on the tissue and then you clean it.
So it won't bend my skin.
No. You have where's your gloves?
The latex gloves.
No, you have the gloves, right?
I don't have the latex glove.
That's okay.
Just use this to hold it. See it
No,
bend
no,
down.
just scrub it in on top. Hold this with paper. Like this, and then you scrub it with.
Just use this one.
But I am in between. We call ourselves blue rooms. So we are in between.
Okay, remove the dental pin. What Elijah is doing now is that we're cleaning the PCB board using the methylated spirits, which can remove the marker. I think it's okay now.
Yeah.
Which one is better? This one or that one?
And this one.
Okay, very nice. Okay, it's time for drilling it. Wait. Safety first. Safety glass first. Wait.
Yours is misty.
Straight, huh? You don't do it straight. You can do that. In this part, we are using my Lotus rotary tool to make small holes on the PCB. Wow, let me see. Can you hold it up? Hold it up into the light. Yeah, nice. Backside, can I see the backside? Oh, okay, good.
Pokey.
So now it's just Elijah's turn to solder. So this is Elijah's first time to do soldering job, and it's apparent that he's really having a hard time soldering these components into the PCB. So I was guiding him, but my mistake is that I should have shown him first how to properly solder a component to the PCB board. So I was telling them to, okay, just solder this out first, and later on I will teach you guys and train you guys how to properly solder components. What's going on? It's okay. You think it's okay? No, how about underneath?
The
Did it properly.
middle part. This one.
Should
Yeah,
you
yeah.
like turn the what
Yeah.
always
Can you turn the other one too? No, this one.
Okay,
1, 2, 3. On this part, Elijah seems to have gotten the hang of it, and somehow he has managed to solder the components onto the PCB board. Now I'm gonna train you guys how to solder properly.
kind of say time you put on an ml goran finish
This
you
one
can
is
still
okay.
No, it's still
adjusting on them
no simpler more. It's not cooked properly. Put
you
some
cook
plum.
him okay warablam
So remove the lead
Be
first, and then
spreading
you cook it first
Yeah.
with. Okay, good. But I think it's strong. Okay, that's it. Off it. Turn it off. Okay, Elijah, not bad. Not bad for a beginner. What do you think?
not bad at all.
So there's Elijah. It's his first time to
Solder.
solder this one. Okay, huh? So did we put the long one on the positive side? Okay, good. Okay, perfect. We clean up and then we continue tomorrow. Okay, insert that one. Make sure it's separated. Okay. Okay, put it there. Make sure it's separated. Okay, let you explain. What are you trying to do?
I'm
So
trying
this
to-
one is connected to
the
12 volts.
12 volts. So we try to see if the what,
At least 4.9 or 4.8 or 5 volts
Yeah.
output. So the positive is the yellow. See if it's going to work now. Try it. Yeah, don't be afraid. You can, you don't touch the tower. You can actually touch the tower. It's not going to electrocute you. It's only it's only 5 volts. Put it there.
we got there. Slipping,
What is it?
slipping on my finger.
Okay, 4.9. Okay, it's time to test it to the actual biometric machine. Okay, so there was a little mistake with our circuit and I had to create a jumper. As you can see, this wire here, this wire. So I had to bypass the circuit and create another hole here for the 10 microfarad capacitor to go to that circuit, and also for the 1 microfarad capacitor I created a new hole on that side. And to complete the circuit, this wire will go to this side to the transistor. Let's try. Okay, check. Okay, so it's drawing ampere of that. It's wetting.
30, 35, 30, 26, 30.
At least it's 0.3. 0.3 is the normal, 0.27, that's good.